Hello everyone, so today we'll be doing math circle theorem. First we have to review the theorems that we have to know, which is there's 7 of them. The first theorem is alternate segment theorem, where the angle that lies between a tangent and a chord. So this is a tangent and this is the chord. So any angle that lies between a tangent and a chord is equal. The second one is angle at the center. So this means that when there is an angle at the circumference is basically this whole thing, but this angle is at the circumference and this is at the center, which is shown by a dot usually. That means it's twice the size. So the next theorem is angles in the same segment. So this is segments usually come in a shape like this. So they're like connected. If you draw a line like this, they'll be connected together. So the angles in the segment are always equal. So we can see these two angles are going to be equal. Then we have angles in a semicircle. So semicircle, it means half, so like the radius. Angles in a semicircle, there will be one that's always 90 degrees. So chord of a circle. So this just means that the perpendicular from the center of a circle to the chord, it just splits it into like two equal parts. So these two are always going to be equal. Next is we have cyclic quadrilateral, which means opposite angles in a cyclic quadrilateral is total to 180. This also, a cyclic quadrilateral will always touch the circumference, or else it's not a cyclic quadrilateral. And then finally we have tangent of a circle. This means the angle between a tangent and the radius is 90, so this one. And then tangents meet at the same point are equal in length. So now let's do this past paper. I already solved a few questions which were easy, so I'm just going to go into this 4-mark question, which is a bit harder. So here we have a cyclic quadrilateral and we have to find the value of y. So here we're going to use some algebra too. So first let's identify the opposites, which is this and this. So we can see from here these two only have x, and we know that the opposite should equal to 180. So first we're going to solve for this and find the value of x, which we can use to substitute later and find the value of y. So let's write down 2x plus x plus 60 equals 180. So now let's add the like terms. So that's 3x plus 60 equals 180. 3x equals 180 minus 60, which is 120. And now we have x equals 120 divided by 3, which is 40. The value of x is 40. Now we have to do this, which is also 180. So let's write down 4x minus 87 plus, I think it's 2y. No, plus y. Just y equals 180. So here, let's substitute 4 times 40 minus 87 plus y equals 180. So 40 times 4 equals 160 minus 87 plus y. So let's subtract 160 with 87 and we get 73 plus y equals 180. So then we go down and then we do y equals 180 minus 73, y equals 107. So here we just used one theorem, but it was mostly algebra. So now our next one. A, B, C, D are points on the circle. PQ is the tangent to the circle at D. Angle BDQ is 55. Complete these statements and give reasons for each answer. Angle BAD equals dash because dash. So let's identify BAD. BAD. So this angle. Okay. So now we can see here that the theorem alternate segment works here because BDQ and DAB are alternate, and it's also a segment. So let's write that. So let's write that down and write our reasoning. So it's 55 because alternate angles in a segment are equal. So next we have to find angle BCD. B, C, and D. So this angle, and we have to give our reasoning. So now that we know this is 55, okay, we can see this is a cyclic quadrilateral, so we simply do 180 minus 55, which is 125. So let's go and write that down with reasoning. Angles opposite in a cyclic quad add to 180. Okay, so that was it for today's video. Thank you guys for watching. Yeah.